I'll start to explain why this strange title. I'm a physicist, so will not expect this kind of title. But since it should be very tutorial talk, I decided to say why we're doing something instead of details what we are doing. And this is one of explanation. So when I was at school, more or less at your age, the world population was 3.5 billion in Polish milliard. Now we have 7.5. So within one generation, it doubled. And in mid of 21st century, it will be 9.5. And a different estimation where it saturates, if it will saturate. And some people claim 12 billion. And this is something we should really worry. And it comes together with increase of life standard. And this is something good. And we want that life standard will equalize in the world. So that's also natural. And if we look for this list, and what is shown here is kind of an index claiming what is a living standard given country. It's calculated on a value of salaries, life expectation, and also education level. That's also important. And here is how much of electricity we need per capita. And there are some, of course, differences due to climate differences, like Canada or Australia on top, because either very cold or very hot climate. Poland, somebody look where we are. We are somewhere here. So we are very much developed country and relatively rich. This is something people will be surprised to hear, because all our statement, politicians claim that everything is strategy, bad, and so on. It's not true. But there's a long, long list of countries which would like to join us on the top of this list. And this means that we need more and more electricity. And I gave you that we have 7.5 billion of people living now on the Earth. And 1.2 billion of people are living in an area without electricity. It's even for us difficult to imagine. And mostly in Africa. And this shows how it will change in time. So you see there's still number of people living in area without electricity is growing. And only in like around 2025, it will reach some maximum and start slowly drop. Another region still a problem is Asia. So that is present situation. So if we look now about expectation, estimation, this shows what is at the moment of my moment, 2010. This is the old power installation to generate electricity. And expectations say that we should double around 2050, so around 30 terawatts. And this is, I think, the most acceptable statement that we need more and more and more energy. And that's we should very worried. And why we should be worried about this, and why I gave such strange title of my talk. And one of the things we should really be worried is emission of so-called, this is CO2, but that's not important that it's CO2. Rather, it's a gas which reflects infrared and will lead to change of climate. And each year, amount of CO2 in atmosphere is increased by 6.2 billion of ton, billion in Polish milliard. So that is something we should really worry. And it's another thing. Many of you heard about situation in Australia, that we have increasing area which is not protected by ozone. Amount of ozone in atmosphere is reduced each year by 3%. So this is also another very bad news, and this is something which already we can observe in this area. The number of cases of skin cancer is increasing rapidly because ozone is protecting us. It reflects or absorbs UV, this hard UV so-called. And now new data says that around 30% of area of Earth is already so polluted that we should not live there. This is something also very worrying situation. And if I show later a number of civilization-related illnesses like cancer, for example, is rapidly increasing. And so we develop, we are richer, but we're living in very polluted now areas. So I call it black scenario, that we should double more or less production of electricity. This is what I already gave you, because I would like to convince you that we have other solution. And probably if we will be following these new ideas, we'll not need this amount of energy and will save our world. So these are official world data. What will limit our growth? And number one is very surprising for many of person is deficit of energy. This is a number one task for us to solve it. Number two is water deficit. It's not that we are short of water. I mean the water which is clean enough for us to be consumed, because clean water starts to be a big problem. And food deficit, because our population growing so rapidly, that start to be pollution and spread of some civilization-related illnesses. So these are top things, very worrying, and top for us, for scientists, to be solved. So about electricity production. I use the title coal dominates, or I should say coal is a king now. Because if we look for other sources, what is used to produce electricity now in the world, nearly 40% comes from coal burning. So that's data for whole world. And all other sources, nearly equal, those 40 to 60% more or less. And if you look for this gas, oil, nuclear, we consume it in enormous amounts. And the only part we should not worry so much is so-called renewable. Otherwise, we are burning coal, we are burning gas, oil, and this will finish soon. How soon? It depends, because predictions say that we have enough of oil, for example, for 20 years on present stage of consumption, but then it says that new sources found and so on. But probably you are the last generation. We should not worry about availability of coal, gas, or whatever. Also, the claim that Poland is richer of coal. It's not true, actually. We have coal enough for more or less 60 years of production at this level. So that's also situation. Now, if we use them to produce electricity, they create a lot of pollution and problems. And especially in Poland, it's now a lot said that coal is our precious things, and we should keep the coal. We should go against the European Union indication and so on, and we'll use clean way of burning coal. So this is amount of CO2 emitted for kilowatt hour. And if we use this clean way of producing, we reduce it here to this amount. Still is the most dangerous for environment way to produce electricity. So this is not true that coal can be used to produce electricity in the way that will be not affecting environment. That's new. In this sense, nuclear power is probably the most safe, but I will show you also other relative. This is not fun. This is actually wedding in China. And I don't know if you would like to have such wedding, because they are in gas marks, because the level of pollution is so horrible in China, and they pay the price. I'll show later the dynamics of a increase of pollution in China. And now new data say that each year around 6 million people are dying because of pollution. And 10% of them in Poland, in Europe, and the worst situation is in Poland. Now there are different data, official now even statement in our parliament are around 46,000 people a year are dying because of pollution. And we use a name, a tiger of economy, China, India, and so on. So this shows increase of emission of CO2 in China. So they paid horrible price for this fast development. And now each year, China is #1 emitter in the world. USA is #2. And they emit around 6.8 billion of CO2 each year. And it's not only CO2, because equally dangerous or more dangerous methane, and all other things which are emitted when the coal is burning. So why we should worry? Till very recently, many people quarreled. Do you have climate changes or not? Now we know that we have them, and that different estimation. What will happen at the year 2050? This is important for you, not for me, unfortunately, but for you, yes. And that two predictions. One, if we rapidly change the way we now develop and we reduce emission of CO2, where temperature will increase around 1.5 Celsius to 2.5. If we keep development on the way we do it now, it will increase by 5 to 6 Celsius. It means enormous area of, for example, Africa, Asia will change to deserts, and it will be catastrophic. Some countries will disappear. In Europe, some countries will be under the water, Denmark, Netherlands, part of Poland as well. All this area close to the sea will be affected. East coast of USA will disappear, and so on, because the water level will increase. So that's a scenario which is not far away. It's quite close. And that's the trend we are observing, that's this emission. The alarming level of CO2 in atmospheres was claimed that we should never pass 400 ppm. Unfortunately, we've done it already 2 years ago, and it's still increasing. So that's the situation. So I said that it's around now above 6 billion, 6.8 billion of CO2 added to atmosphere each year. And electricity generators produce around 6.3 billion of tons of CO2 each year. So we should do something here. That's area we should be very worried, and we should change some decisions very fast. So do we have something which will be forever? Forever in sense of our life's length. I mean, so we should not worry next, say, 3 billion of years, for example. And of course, we have something which we have in enormous amount. It is solar energy. And sun is a huge generator, so that's a number, enormous one. We are far away from sun, something like 150 million of kilometers. So amount of this energy coming to Earth is reduced. This is the amount. And if we learn how to use it, then we can cover all our expected, even for future, demand for energy. So how it is at present? The area is called photovoltaics. Photo is from light, and voltaics from Volta, famous Italian scientist, and we know him also from volts and so on. So that's photovoltaics. And this area was still a few years ago nearly nothing compared to other sources of energy produced, and now rapidly starts to increase. So it's expected that it should reach like 10% of electricity produced quite soon. So it means like 2030 or whatever. Unfortunately, not in Poland. In Poland, the development photovoltaics is close to nothing. How it looks like, so this example, we could put them and they are normally not good for agriculture. So this is example. One of such facility. Here is another. And this is a medium-size system. But this system will reduce the use of coal, for example, by more than 1 million tons a year. And we use something which is available in enormous amounts for producing such panels. We use silicon. And silicon, if you go for beach here, you can now look for a beach in different way. That now this is a source of energy. You can change of sand to silicon and produce such panels. So we are very lucky because materials to produce such devices, some panels, is available in enormous amounts, so there will be no problem for this. This is something we work on. I will not explain details. We work on special arrangement to improve lab collection. So we're growing such fancy structure, three-dimensional of sizes of something difficult to us to imagine, nanometers. Idea is that that helps to trap the light. So this area we're working to making more efficient solar cells. So that's very schematic how we are doing, but I will not go to details. Now I'll go to something I call green scenario. Black one, it means that we'll follow, we need more electricity, we'll produce new power generators and so on. But there's a lot of solutions which will help us to reduce the amount of energy we need. So for what we need electricity? And I put here things which I will shortly discuss: illumination, some facilities we use in home, heating or cooling, and I'll show how much of this energy is just lost because we are not bright enough. And one of the things, and you cannot imagine life without computer now and all these funny things, but computers now using more energy than whole air traffic. And that's something showing how our civilization is changing. So first example, lightning. Everybody already noticed that even in many countries now it's forbidden to buy classical incandescent lamp. Why? Because it's not efficient. Efficiency, if you just put normal lamp, like this lamp, it produces more or less 5% of energy that comes in, is used for illumination, 95% is lost. So this is the most expensive way we heat our houses. So this is an example how we can help. These lamps, now you can buy many shops, and IKEA, for example, is not saying normal lamps, now just only that one, based on semiconductors. LED means light emitting diodes. And such one lamp is 40 kilograms of CO2 less to atmosphere. Now, if you multiply by number of lamps we're using, and this is now counted in billions, you may notice how much we can now reduce demand for energy. So these are some data got from American sources. So just replacing some modest part of lamps with these modern ones, we can reduce emission of CO2 by nearly 500 million of tons a year. And what is important, then we'll save also an enormous amount of money. And it shows, and many people ask the question, why we should finance science, for example. The program in the United States to make such lamps was done for a period of 10 years. Already after 2, they changed the program because developments were so fast. And this program costed around $1 billion US. Now saving for USA estimated will be more than 100 billions of dollars. So $1 put gives 100 back. So it gives the answer, should we finance the science? The answer is yes. And many of saving is possible. And now suddenly, if we change like half of lamps to modern ones, we should just go in reverse direction. We should just reduce production of electricity. We have too much of electricity suddenly. So that's one example. Now if we go to houses. Now if you look for houses, a lot of energy goes for either heating or cooling. We use some like fans, air conditioning system in summer, and just heating in winter. And this is, it helps us to survive. In summer it's too hot, in winter too cold, but it has no sense because we have technology available to change the situation very easily. So just a little of physics. This is a spread of now light. So this is intensity, this is a wavelength from our star, sun, what comes to the Earth. And only part of this is useful for us, and the rest just generates the heat, this part. So we should do something to block this part of sun radiation, and then we'll immediately solve the problem of overheating of our houses. So I speak now about something which is now called E-low, energy low windows. So we can coat windows in the houses, something which will be transparent for visible light and reflect infrared. And it's very simple. We have such materials, we have such technologies developed. So it's only a question of taking decisions. And new norms for houses, and that's slowly coming, but that's something we should know. This is picture in infrared showing that even if we use this all modern things in many cities in Poland, you see now they put something to block escape of the heat from houses. It's good. But then we have one weak point, windows. And the heat is escaping from windows in the winters. But we need windows because otherwise I cannot imagine a house without windows. So what to do? So just once more a little of physics. We have, everybody knows that every object of given temperature is emitting in different area of radiation, and especially army is using it. They have so-called noctovisors to see in infrared. But if we take typical temperature we have at houses, and I just put it in Celsius here, this is area of emission. And this is very bad news, because it mostly comes, the peak will be close like 8 micrometers, 10, and atmosphere is transparent for this light. This is why if we go in the winter, many of people can die because of frost, because we are emitting, and this is very rapid process. So this shows this hole in atmosphere of this area, and this is why that we have big problem with escape of the heat. And sometimes in the winter, you can notice two cars standing. One is covered with ice, and second not. Why? Because already some companies, and especially first was Volvo, cover the windows something which reflects this part of infrared. And once more, we have this materials, and now we have this technology. It's not very expensive. So if we use it, we'll block escape of this area of infrared. And that means that will save enormous amount of energy. Now about electronics. Already mentioned that electronics now is one of major player in the area of energy demand. And this, everybody wants to have computers, and we use it for different purposes, officially for work, but many people use also for games and so on. But you may notice that something is changed, especially monitors improve a lot. Nobody uses this kind of classical tubes and TV and so on. Well, we have modern ones. But I do not have here. But each computer will have one weak point, and that's something we should solve. Now, if we put some information of programs, it should be stored there. So we have so-called memories inside. And the fast working memories need all the time to be charged. And it means 40% of electricity consumed by computers is going for this memories. So now we should find new type of memories, which will be non-volatile, so-called memories. And this is many groups in working on semiconductors and on materials like silicon, gallium arsenide, and so on, are looking for this kind of memories. Will be fast enough to reduce, if we solve it, 40% less of energy. And already gave you that computer use now more than all the air traffic. So this is an enormous problem now to be solved, and probably will be solved. Now something from completely different areas. I mentioned that pollution means enormous increase of such illnesses like cancer. On average, each of here will live 4 or 5 years shorter than should because of pollution in Poland. Poland is the most polluted country in Europe, and some data are tragic. Now you can find on some of the newspapers information about amount of dust in the air or something. And we have different norms at the European Union. So even the different norms, you look them, you found now, I checked it today, and in Warsaw was close to 200%. And information that we have moderate pollution. I don't know what is moderate. I mean, we are breathing it, and number of cancer cases, especially lung cancer, is increasing rapidly. So darker color means more cases. And you'll see something surprising. The higher development level, the more cases. There are, of course, some claimants that, okay, that we have this because people are checked more often and so on, so that's not to the end question of pollution, but pollution is equally important here, and that's something we should do. And what to do, what task of scientists to do? This data show what is the chance of successful treatment when we discover cancer at very early stages. And then chances are nearly 100%. So if we develop new techniques to detect such illness like cancer quite very early stages, this will be very easy to be treated illness. Now, if we delay this detection, or if it's already spread to many organs, it rapidly drops. So Now, all our efforts is to find new ways to detect the cancer. What I'm showing here, many of such research is done on animals, so these are cases of mouses. And I'm showing something which allows us to localize where is the tumor. And I'm showing you because something is very funny, because often material first developed for application, for example, in integrated circuits. And suddenly turned out to be very interesting for application in biology, to work like kind of as sensor allowing now very early detection of that. So, for example, we work using these materials, which first we use to produce isolating layers for transistors, and which were used then in integrated circuits. And now we work to detect the lung cancer. And why lung cancer? Because there are data about number of cases and a survival rate. And normally, for many of illnesses, data improve with each year. There are new medicines coming, techniques and all. But lung cancer is very difficult. And you may notice the progress is relatively slow, if any. Why? Because it's usually detected quite late. And it's very difficult to be localized. It's spread. So that's something. So what I'm showing here, the special markers which we develop using the same material we first studied for electronic circuit. And when introduced, it comes to cells attacked by tumor. And it allows to detect this area. If the organ is not attacked, you will not see them. If it attacks, it gives special emission and allows us to detect. And why it is important? Because normally, doctor takes a risk. If he operates the patients, he really takes the risk because it's very difficult to say. A biopsy, which normally is by doctor, is too slow. So normally the rule is to operate more than is needed, sometimes even 2 centimeters more. And especially for some vital organs, lungs, brain, and so on, it can be tragic for patients. But now this allows us, using simple tool like laser have, the doctor will see which area is attacked. And just to indicate area of operation is needed. And that's very important. And that's also area we should work and just develop these new techniques of detection. So another thing we should very be worried, we consume antibiotics in enormous amounts. Everybody is surprising. What means enormous amounts? We are not eating antibiotics. Maybe I got it 2 years ago. It's not true, because they are used in enormous amounts till recently. Now it's forbidden in the Union. I hope also in Poland, because we need a lot of new food because our population is growing. So that new things are enormous animal farms. And farmers using antibiotics in enormous amounts. So we are eating it in a meat. And it means that now a lot of bacteria are resistant to most of known antibiotics. And it starts to be big problems. So many of illnesses we claim that it's already solved. They disappeared, are coming back. And that's something. And there are very different ways to fight bacteria and to do sterilization. Normally, in hospitals, they use high temperature. So it kills most of bacteria, not all. Now, it's very popular to use silver nanoparticles. So you can buy it in every form. And it's alarming new data because this comes to water, it goes to waste, and so on. And now, suddenly, the new data claims that fantastic, they are very good, but they are not very selective. It means that now efficiency of water cleaning, for example, in some places is reduced because it comes with water and also kills the bacteria we need, for example, for cleaning waste. So that's also a big problem to be solved. Develop new way to protect us against bacteria And to also reduce energy, because now amount of energy used for sterilization, for cleaning is very high. So this is also something to work on. And once more, you'll like to see here, there's several ways to do it. The most popular is use metals. Silver, already mentioned. Copper is used in large amount. So metals are very good for this, some of them, but they are very also not selective. So that's also a problem. So that's also the things. We turn our attention to materials we studied for very different applications. Zinc oxide for this coatings of this energy low windows, especially dope. Titanium dioxide is material used for this. And also check some materials we develop and technology to produce some transparent electronic devices and this kind of things. And suddenly we found that they can be also used here. So once more coming. I will not explain what this data means. The larger value means the more efficient of killing bacteria. So what we found, we check long list of bacteria common for hospitals. Now people claim that you should be very healthy to go to the hospitals. The number of cases of complication after a very simple operation, some people die after very simple operation because of widespread of this bacteria hospitals. So this is the last place to go if somebody is ill. That sounds very strange, but that's unfortunately is true. So we check 16 types of bacteria common for hospitals. And now we develop them, so we can count all the equipment used by doctors. So these are tests of this. And some of this coating also protects against rust of this also. But technology development also allows to coat paper, mask of doctors, gloves, and so on. So that's also very interesting area of research and very related because we start, for example, looking for materials good for electronics. Then we found that we can use them in photovoltaic. Then suddenly we came to application in biology and medicine and for just the very efficient blocking development of bacteria. So that's something. So this comes me to the end because I'm just use the strict saying about how important can be some works done in the laboratories, but not because we get good publication or something, but we can solve many of problems. And if we want to develop, so the question in which you should answer, what next? Because already your generation will be very much affected. If we do nothing, you will be leaving the world, which will be really quite dangerous. So that's more or less, I think, all what I want to say. And as I saw it, it should be very tutorial, so that's the trick I use. Thank you.